Okay, so our first example here tells us to find the 6 trigonometric ratios for the following triangle. So we've been working with 2 trig ratios so far, which are sine and cosine. So let's go ahead and make sure we know what all 6 trig ratios are. So we've got sine, cosine, and then tangent. We've talked a little bit about tangent already. And then we have their reciprocals. So what a reciprocal is just the opposite or just a flipped fraction ratio. So for example, sine is the opposite over the hypotenuse. So the reciprocal of that would be the hypotenuse over the opposite, where we're just writing in the other direction. So each of our main 3 trig functions all have a reciprocal function to go with it. So the reciprocal of sine is cosecant. The reciprocal of cosine would be secant. And the reciprocal of tangent is cotangent. And so the way I always remember that is each pair, the original trig function and its reciprocal, each pair has one co in it. Sine and cosecant form a reciprocal pair. Cosine and secant form a reciprocal pair. Tangent and cotangent. So you see how each reciprocal pair has one of them has co in it. And that, because I always used to get cosecant and secant backwards. Because it just seems like cosine should go with cosecant. Okay, but they don't. Each pair has one co in it. And so then let's go ahead and write their abbreviations and then what their actual ratios are. So we've got sine, cosine, tangent, and then we have cosecant, which is abbreviated CSC, secant, which is SEC, and then cotangent, COT. So what we're having to do, we're going to have to make our own triangle here. So let's say that the sides are A, B, and C. We're going to let C be the hypotenuse. So this side length is A, this one is B, this one is C. Okay, so across from our angle A, we're going to have, across from our side A, we're going to have the angle alpha. Across from B, we'll have this angle beta. And then across from C, it's normally gamma, which I can't draw. So I always just put a capital C. Or because it's the right angle, we're never going to find the trig ratio from that right angle. So we really don't have to worry about naming it.
What does gamma look like?
I can't draw it. I mean, you may look it up.
That's what I was thinking of, like at church when you draw the thing.
Well, okay, so let's get back. We're going to find sine, cosine, tangent. So we have to do that from an angle. So we're going to pick the angle alpha. So we're going to find sine of alpha, cosine of alpha, tangent of alpha, cosecant of alpha, secant of alpha, and cotangent of alpha. So sine is just a ratio of the opposite over the hypotenuse. So in this case, that would be A over C. Cosine from the angle alpha is the adjacent side over the hypotenuse. So it would be B over C. And then tangent of alpha, tangent is the opposite over the adjacent. So we haven't been dealing with that as much. Tangent is the opposite over the adjacent. So it would be A over B. Now cosecant is the hypotenuse over the opposite. So it's just the reciprocal of sine. Secant is the hypotenuse over adjacent. So it is C over B. And cotangent would be the adjacent over opposite, which is B over A. Okay, so we want to find the 6 trigonometric ratios for the ordered pair 3, -4. So we want to use the x-axis as one of the sides of the triangle, and our angle alpha is always at the origin. So it's our central angle, just like we've been doing so far. So what we do is we're going to plot the point 3, -4. So we would go right 3, we would go down 4, and so right here is the ordered pair 3, -4. If I make a right triangle there, we use the x-axis as one of the sides, just like we always do, and draw that height to the x-axis. So it looks like that. So now what are our side lengths? Well, I went right 3, so my side length here is 3 on the x-axis. Then I went down 4, so the height of this triangle would be 4. So before I can find all of my trig ratios, I have to find the 5th side. So because it's a right triangle, we can use the Pythagorean Theorem to find the missing side.
Radical 15.
You're close.
I did it in my head.
Yeah, you forgot a 1. So I've got leg squared plus leg squared equals the hypotenuse squared. So 9 plus 16 equals c squared. So 25 equals c squared. So c equals 5. So this is a 3, 4, 5 right triangle. So do you guys remember all of the Pythagorean triples, right triangles? So there are 3 right triangles that are very common to happen where all 3 sides are integers. Okay, so it'll do you some good if you'll learn these later on. They're called a 3, 4, 5 right triangle. There is a 5, 12, 13 right triangle. And there is a 7, 24, 25. Right triangle. And so what that means is the side lengths are in this ratio, 3 to 4 to 5. 5 to 12 to 13, 7, 24, 25. But now they can have different forms. So like think about 3, 4, 5. If I multiplied all of these by 2, then that would be a 6, 8, 10. That would also be a Pythagorean triple. If I multiplied them all by 3, 9, 12, 15, will be a Pythagorean triple. If you can start identifying these, it will save you time from having to do the Pythagorean theorem every time, if you recognize these triples. Now, this is not make or break. Like, you don't have to have them memorized, but it makes the math a whole lot quicker. Like, as soon as I saw 3 and 4, I knew that was a 3, 4, 5. I didn't even have to do the work. But, anyways, that's something from geometry that could be useful if you remembered it. So now what we're asked to do is find our 6 trig ratios from our central angle. So we're going to call this central angle here alpha. We don't know what it is. I need to zoom in so I can draw that better. But this is alpha. Okay, so I would say sine from the angle alpha. Now, here's the deal. What quadrant are we in? The 4th. So we know that our ordered pair was actually 3, -4, but our sides of our triangles are not really negative. So I know since I'm in the 4th quadrant, all students take calculus. I know cosine is the only one that's positive. So I know sine is going to be negative. Sine is the opposite over hypotenuse, so it would be -4/5. Cosine again, because I'm in the fourth quadrant, is going to be positive. It's the adjacent over the hypotenuse. Tangent of this angle. I'm in the fourth quadrant, so cosine is going to be, cosine is the only positive one, so tangent is going to be negative. Tangent is the opposite over the adjacent, so that would be negative 4 over 3. And now to find the other ones, I always just did the reciprocal. So the reciprocal of sine is cosecant. So cosecant of alpha would be negative 5 over 4. Secant of alpha is going to be positive 5 over 3. And then cotangent of alpha is going to be negative 3/4. So even though we don't really use these in our saying, we know that if its reciprocal is negative, then it's also going to be negative. So this is only for the main three trig functions, and we have to know its reciprocal, which one goes with which, to know what is negative and what is positive. Okay, next one. Find the 6 trig ratios for the ordered pair 12, negative 4. So again, this is not going to be a triple. So I know I'm going to get a pretty ugly number here for the hypotenuse. So 12 is going to be kind of hard to count over, so I'm just going to draw. I know on the x-axis I'm going to the right 12. Then I know I'm going up by 4. I'm going to go down by 4. Good call. So I'm going to write 12 up here then. Okay, that's a bad. So again, I'm in the fourth quadrant. Here's my right angle. Here's my angle alpha. This is the central angle. So we're going to find our 6 trig ratios. Okay, so because we have all students take calculus, cosine is going to be the positive one. So sine of our angle alpha. Well, first I need to find the hypotenuse, right? My missing side. So I would use the Pythagorean Theorem. 4 squared plus 12 squared equals the hypotenuse squared. So 16 plus 144 equals c squared, which tells me c squared equals 160. I take a square root. So the square root of 160, that would be 16 times 10 underneath. So that would be 4 radical 10.
What's that side of
14? You mean 144? That's a bad looking 4. Yeah. You thought I was trying to sneak a gamma in there, didn't you? Huh? Your calculator do this for you? Square root of 160? Did it give you 4 radical 10? Okay. So now our big problem we're going to have now is we're going to have to rationalize this hypotenuse when we start putting in our ratios, because we can't have a radical in the denominator. We'll get there when we get there. So because I'm in the fourth quadrant, sine is going to be negative. So it's going to be negative opposite over hypotenuse. So negative 4 over 4 radical 10. Let's just leave it like that for now. We'll come back and rationalize them all at the end. Cosine of our angle alpha is going to be positive because I'm in the fourth quadrant. It's the adjacent over the hypotenuse, so that would be 12 over 4 radical 10. Tangent of my angle alpha is the opposite. It's going to be negative, and it's the opposite over the adjacent. So it's negative 4 over 12. Okay, so let's go ahead and I want to leave them like this, because it's going to be, when we flip it, it's going to be okay because the radical is fine when it flips to the numerator. So don't erase these numbers because these numbers will help you in the end. But we need to reduce them and we need to get rid of the radicals in the denominator. So right here I have a 4 being multiplied in the numerator and denominator. So I can reduce that 4. So this is the same thing as negative 1 over radical 10. Basically those 4's cancel and you're left with a 1 in the numerator. And then 1 times radical 10 in the denominator is just radical 10. And then the way we rationalize is we multiply by whatever's underneath the radical. So because I have a radical 10, I'm going to multiply by radical 10 on top and bottom. And when I do that, that's going to give me negative radical 10 over, and then radical 10 times radical 10 is a positive 10. So sine of alpha would be negative radical 10 over 10. But now when I flip it here in a second, this one's going to be important to me. Okay, so those are equivalent numbers, but I had to rationalize the denominator to get it in the correct form for what they were asking for. Right here I've got 12 over 4 radical 10. So similarly, 12 and 4 will reduce. This will become a 1, this will become a 3. So this is the same thing as 3 over radical 10. And now to rationalize that, I need to get rid of the radical 10 in the numerator and denominator. So I'm going to multiply by radical 10, and that's going to give 3 radical 10 over 10. So again, that would be my answer for cosine of alpha. And then for tangent of alpha, there is no radical, but I have a fraction that will reduce. Negative 4 over 12 is negative a third. And that would be reduced, so that would be my tangent. So I found 3 of my trig ratios. Now I need to find the other 3. So the reciprocal of sine is cosecant. So I'm just going to flip I'm going to find the reciprocal of sine. Well, I could flip this one, but what would happen if I flipped this? Then the radical would go to the denominator, and I have to rationalize again. So that's something we don't want to do. So I'm going to go back to a previous form here, where there was a radical in the denominator, but no radical in the numerator, and just flip this. So negative 1 over radical 10, which is negative radical 10 over 1, or just negative radical 10. You could use this one, but that'll still reduce with the 4 over 4. So the reduced form, it still has to be reduced, but this with the radical in the denominator is the perfect one to flip. Now, if you erase this, you can flip this one, and then you just have to rationalize again. So you'd multiply by radical 10 on top and bottom, but then you would have 10s that on the outside that would cancel. So you'll probably do that before you finish the class. You'll probably erase something you didn't mean to.
Your attention, please. In order to have one of our monthly drills today, we're going to do our lockdown drill. This is a hard lockdown. Make sure you lock your doors. Get your students in a quiet area. But this is a drill. Go into that lockdown at this time. Thank you.
Okay, so next we've got to find secant of alpha. So secant would be the reciprocal of cosine. So again, I could flip this one, but I would have a radical in the denominator. So I'm going to flip this one because that gets rid of the radical in the denominator problem. And that would leave me with radical 10 over 3. And then cotangent of alpha. That would be the reciprocal of negative 1/3, which is just negative 3 over 1, or negative 3. Okay, in general, if x and y is any point other than the origin, and we use the x-axis as one of the sides of the triangle, then the following ratios can be used using alpha being the center angle of the origin. So we're going to let R be the radius of that circle. Okay, so that's what it's got written here. R is the radius of the circle. And the way we can find that radius is by using the Pythagorean Theorem. So it would be the square root of x squared plus y squared. Right, that's just solving the Pythagorean Theorem. X squared plus y squared equals r squared. So we would take a square root of both sides to find the r. That's where that comes from. So the radius is r, which is x squared plus y squared, the square root of that. Sine of alpha would be the opposite over the radius. So opposite is the y value over the radius r. Cosine would be the x value over the radius r. And tangent would be the opposite y over the adjacent x. Okay, the next one tells me to find sine, cosine, and tangent for the point negative 15 and 8. And then we're going to introduce something new, finding alpha. So we're going to go ahead and solve to find the missing angle. Okay, so I'm going to draw this situation out. So negative 15 means I'm going to go left 15 and then up to 8. So again, this side length is 15. This one is 8. And I'm in the second quadrant. So I'm already thinking all students. So I know sine is going to be the only one that is positive. Now I need to find the missing radius. So Pythagorean Theorem. The radius is going to be the square root of 8 squared plus 15 squared. So that would be 225 and 64, 289. 60, 225. Yeah, I think that's right.
Excuse me, teachers. May I have your attention, please? Access testing begins today, so Ms. Thompson will be testing. The bells have been turned off. We will change classes on regular schedule, but please be aware that Ms. Thompson is testing. But we will change
Is that 17?
classes on regular schedule just without the bells. Thank you.
So there must be another Pythagorean triple. That's one of them that I don't recognize. But it's an 8, 15, 17. Okay, so if I was asked to find sine of the central angle alpha, sine is the opposite 8 over the hypotenuse 17. Cosine of alpha would be the adjacent over the hypotenuse, and it would be negative. And then tangent of alpha would be negative, because I'm in the second quadrant. Opposite over adjacent. And now I'll leave you this to think about when we come first thing tomorrow. What would I need to do if I wanted to solve for alpha? I can use one of these trig ratios to solve for alpha, which means I want to isolate alpha, just like how we solve for any variable. So how could I get alpha by itself? We'll go over that tomorrow.